Good morning and happy Thursday. This is lesson 32. So if you are at home, you'll have access to this video to complete your lesson and problem set for today. And today we're continuing with division, although we are nearing the end of our division module. And today we are going to interpret and find whole number quotients and remainders, still solving one-step division, but now we're looking at word problems and we're looking at problems with larger divisors. So we've been looking at numbers 1 through 5 as divisors, and now we're going to look at some larger numbers 6, 7, 8, and 9. So let's talk a little bit about that vocabulary before we get started. I've made this anchor chart. Let's see if I can adjust and get it in view for you guys. And it'll be posted here in the classroom, but it just kind of goes over, and I'm going to make my video frame larger for a second. So there we go. It kind of goes over some of the vocabulary. So divisor. Divisor is a number divided into another number. So your divisor in a division problem is going to be your smaller number, okay? The dividend is the whole number that we're actually dividing. So that is your dividend, okay? And you guys should know that your quotient is the answer. So here's your quotient, right? Now, remember, these are our steps. Divide, multiply, subtract, check and bring down, or does McDonald's sell cheeseburgers? Okay. We always double check with multiplication. So here we are, we're looking at our problem down here. We've got our divisor, our dividend, and our answer. And then after you've brought down every number you can and there's nothing left to bring down, this number, the difference that might be left over at the bottom, sometimes it's 0, but a lot of times it's a number. That is called the remainder, right? So there's your remainder. So I'm kind of hoping that this little anchor chart in the classroom will help you guys as we continue to do division. All right, so let's go ahead. I'm going to shrink myself a little bit, and then we're going to take a look at problem 1 together. Now, if you are at home, remember you should have a scratch piece of paper or a whiteboard or some way to solve these problems. So let's think about the first problem together. Remember, these are all word problems, so it's going to require you to use RDW. And we are looking at this problem number 1. It says, we all know that there are 7 days in a week. How many weeks are in 259 days? So what they're wanting you to do here is to draw something that shows what we know about this problem and what we still need to know. So let's go ahead and flip over to my Jamboard here. And what I'm going to do, and hopefully you're going to do this at home with me, is you're going to use a tape diagram to illustrate this, okay? So remember, we had 7 days in a week, and then we're trying to see here, we have 259. How many weeks are in 259 days, okay? So what do we know and what are we trying to figure out? Here's our whole. And what we know, right, is that we have 259 days because the problem said how many weeks are in 259 days. So we know that we have 259 days. We also know that there are 7 days in a week, right? So we know 1 week has 7 days in it. What we're trying to figure out is how many more weeks are over here, okay? So we know our whole. We know we're looking at 259 days. We know there's 7 days in a week. We're trying to figure out how many more weeks we have. So here's 1 week, right? Now we're trying to figure out how many more weeks. So how many weeks make up 259 days? And how could we solve this problem? Okay, so how could we solve the problem? Here's our tape diagram. Hopefully yours looks like this if you're following along with me. And we've talked about why we designed it to look like that. So now let's solve. How would I go about solving? I want you to take a minute and think about it. And hopefully you've decided that you would have to do division. And we would take 259, that is our dividend, and divide by 7, our divisor. And we would have to do our long division process, right? So what we're going to need to do, I'm going to have to shrink myself a little bit more here, is we're going to start in our hundreds place. And I look at my hundreds place and I see a 2. We've been talking about what happens when we can't divide 2 by 7, right? Our divisor is larger than our first number, so we can't start there. We actually have to look at the number 25 to start. How many times can 7 go into the number 25? Or 7 times what gets us as close to 25 without going over? Well, hopefully you've been practicing your multiplication facts and you know that 7 times 3 equals 21. You could also count up by 7s, 7, 14, 21, 28. Well, that's too many, so I have to go back to 3. So I've done my division, and now I have to do my multiplication. 7 times 3 equals 21. Now I do my subtraction. 25 minus 21 is 4. And I have to check and bring down my 9. And now I have to look at the number 49. And how many times can 7 go into 49? Well, I know my 7s, and I know that 7 goes into 49 exactly 7 times. 7 times 7 is 49. I've run out of room, but I would put my 49 here, do my subtraction, and I get 0 as my remainder, okay? Now, if there were a number down there, I would have a remainder, but I have a 0. So I know that there are 37 weeks in 259 days. And because this is a word problem, I would need to write out my answer. I would need to write out a sentence that says, there are 37 weeks in 259 days. The next thing that you would want to do in your division is to check your work. And I'm going to pause here for a minute and let you think about, how would I check my work, Ms. Johnson? Well, remember, we're going to always check our work using multiplication. And we're going to multiply our quotient by our divisor. So I'm going to come over here and I'm going to say 37 times 7. Well, I know 7 times 7 is 49. Carry my 4. 3 times 7 is 21, plus 4 more equals 25. And my answer matches my dividend, so I know I'm right. Okay? So that was our first word problem. Word problems always remind me of like application problems, right? Because we have to do the RDW. We have to read it. We have to draw it, which sometimes is a tape diagram or an area model, or sometimes it's just us solving the problem. And then we have to make sure that we write a complete sentence, okay? So let's go ahead and practice with a second word problem. This word problem is using colored pencils and students, okay? So you guys can relate to this question. Everyone in our class is going to be given the same number of colored pencils. If there are 249 colored pencils and 8 students, how many pencils are each student going to get, okay? So go ahead and kind of reread that and be thinking about how you could illustrate that, how you could draw it. How are you going to draw a tape diagram? What do you know, and what are you trying to figure out? So hopefully your tape diagram, let's go to my Jamboard here, and hopefully your tape diagram will look something like this. So I have to look at my problem here. I have 249 colored pencils, so that's my big hole that I know, right? 249. And then it tells me that there are 8 students. So I'm trying to figure out, if I have 8, I'm going to divide this into 8. I want to know how many are each of these little squares going to represent, okay? Well, how can I solve that? I have to take my 249 and I have to divide it by 8. I've taken that whole and I've divided it up into 8 little parts that represent my 8 students. Okay, and now here I am. Let me get my poster in frame here. I'm going to go through all my steps, okay, to solve. So first, I'm going to start by dividing. I look in my hundreds place. My divisor's too large, so I have to expand over and look in my tens place. So now I'm dealing with the number 24. How many times can 8 go into 24? I have 8, I have 16, I have 24. So exactly 3 times, right? Now I can't put my 3 over my hundreds place. I have to go to my tens place. I've done my division. Now I'm going to multiply. 8 times 3 is 24. Next step is to subtract. I get 0, and my next step is to check and bring down. I get a 9. Well, 8 can only go into 9 one time, right? 1 times 8 is 8. 9 minus 8 is 1. I check. I have nothing left to bring down, so here's a remainder. I have to go up here and put remainder 1. So I know that each of my students are going to get 31 colored pencils, and then I'm going to have one lonely little colored pencil left over, right? Now, I'm not done yet. I want to check my work, so I'm going to come over here and I'm going to take that quotient and multiply it by my divisor. So I'm going to say 31 times 8. 1 times 8 is 8. 3 times 8 is 24. I have to take my remainder and add it. And I get 249, which matches my dividend, so I know I'm right. Now, I want you to think for a second here. How could I change my tape diagram to represent that one little lonely colored pencil left? Okay, so now if I went back to my tape diagram and I erased my question marks, because I know that each student is going to get 31. So each one of these squares is going to have 31 on the inside. But I have one little colored pencil remaining, so I might just draw this tiny little remainder there. Okay? Hopefully that makes really good sense to you. Let's look at one more word problem together, and then I'm going to let you guys go ahead and get started on your problem set. Okay? So let's go ahead, and we are looking at problem number 3. It says Mr. Hughes has 155 meters of volleyball netting. So he has 155 meters of netting. How many nets can he make if each court requires 9 meters of netting? So think about what we know and what we're trying to figure out. Okay, let's go back to my Jamboard here. And we know we have 155 meters of netting, okay? And we want to know how many nets can be made if each court requires 9 meters. So we know that one court is 9 meters. We just don't know how many more we can make, okay? Well, how can we figure that out? You got it. We have to divide. So we have to take our whole number. That's our dividend, and our divisor is 9. And we're going to do the same thing we've been doing. I look in my hundreds place. My divisor's too large. So now I'm going to start with 15. And how many times can 9 go into 15? Well, I know that 9 times 2 is 16, so that's too many. So I have to say 9 times 1, right? 9 times 2 is 18. 9 times 1 is 9. So 1 times 9 equals 9, and 15 minus 9 equals 6. Okay, now I have to check and bring down, and I bring down my 5, and I start all over again. Now this one's a little bit larger. How many times does 9 go into 65? And I have to kind of know my facts, right? Well, I know that 9 times 7 is 63. So I'm going to put a 7 because then I know that 9 times 8 is 72, and that's too many. So 9 times 7 is 63. I have to subtract. 65 minus 63 is 2. I check. I don't have anything else to bring down. Okay, so that means I've got a remainder of 2. Now, I have to go back and check my work using multiplication, right? I have to take my quotient and multiply it by my divisor. So I'm going to say 17 times 9. We know that 9 times 7 is 63. And I know 1 times 9 is 9, plus 6 more is 15. Oh, sorry about that. So I got 153, but I still have this remainder of 2, and I have to add that on. 153 plus 2 is 155. My dividend is 155, so I know I'm right. So I know that I can fit 17 total quarts using 155 meters of net, and then I'm going to have 2 left over, right? So I'm going to have 2 meters left over that I could just tack on here, remainder of 2. Okay? So that pretty much wraps up today's lesson. Again, it is just long division, but now we're looking at word problems, and we're trying to figure out from the word problems how to solve and what to set up. So let's go ahead and take a look at the problem set so you'll know what you need to do. If we scroll down and find Thursday, you're going to find your problem set. And I'm going to have you open that up. And let's see. I'm going to ask you to do number 1. And then I'll have you do number 3 and number 5. So I'm going to give you 3 problems to do here. Let's look at the instructions together, and then you can log off and work on the problem set. It says solve the problems, draw a tape diagram. If there is a remainder, edit your tape diagram at the end. And you'll want to solve with division, right, to be able to solve. So these are all word problems. It's really just like what we just went over. Make sure that you are ready to log back in at 10:30, or if you're in my afternoon group, I think you're logging back in at 12. Let's see. I think I had you guys, well, if you're in my afternoon group, I will tell you what time to log back in, okay? But make sure, whether you're in my morning or afternoon group, that when you do come back, that you are, you've got your problem set done and you're ready to discuss, okay? So just a reminder that I will be able to see if you've watched this video. And don't forget that we are working towards that reward party, and I know you want to attend, so make sure you're working hard and getting your work done. Okay, good luck. See you here in a little bit.